x square into d square y by dx square is y2 plus x into dy by dx is y1, and transfer minus y to the left hand side, minus y becomes plus y is equal to 0. d by dx of dy by dx is equal to d by dx of f dash x. d by dx of dy by dx is nothing but d square y by dx square is called the second derivative, and d by dx of f dash x is nothing but f double dash x. dy by dx is equal to differentiation of x cube is 3x square plus differentiation of tan x is secant square. This is first derivative. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important concept, that is regarding second derivatives as well as the problems on mean value theorems. Very important concept. Definitely you will expect one 5 marks question and one 3 marks question from this concept. Now let us move on to the second derivatives plus. So in second derivatives you will going to get one 5 marks definite sure question from this. Now what is a second derivative? Second derivative, or it is also called as a successive differentiation. Now let us consider a function. Let y is equal to f of x. Then the derivative of this dy by dx is f dash x. So derivative of f of x is f dash x, denoted as dy by dx. So differentiating again with respect to x can be denoted as d by dx or dy by dx is equal to d by dx of f dash x. d by dx of dy by dx is nothing but d square y by dx square is called the second derivative, and d by dx of f dash x is nothing but f double dash x. So therefore d square y by dx square is called the second derivative. F double dash x is called the second derivative of a function. So if you differentiate a function one time, you will get first derivative. If you differentiate again, you will get second derivative. D square y by dx square is equal to f double dash x. So first derivative can also be denoted as y1, or it is also equal to y dash. Second derivative can also be written as y2, or it is also equal to y double dash, right, like this. So this is how we are going to represent a second derivative. So this is called the second derivative. Suppose if you differentiate this again, you are going to get third derivative, fourth derivative, fifth, so on, nth derivative, that is called as successive differentiation. So if you differentiate n times, you are going to get nth derivative, that is called first, second, third, fourth, five, like that, that is called as the successive differentiations. Now in your syllabus you are going to study only second derivatives. Now move on to the problems. Now what is the first problem? If y is equal to x plus 3 whole cube, find d square y by dx square. Now just what is given? Y is equal to x plus 3 whole cube, differentiating with respect to x. So if you differentiate this, dy by dx is equal to d by dx of x plus 3 whole cube. So this is f of x to the power of n. What is n here? N is equal to 3 into x plus 3 whole to the power of 3 minus 1 into d by dx of inside function, that is x plus 3, that is 3 into x plus 3 whole square into differentiation of x is 1 plus 3 constant. This is your first derivative, dy by dx. Now differentiate again. Differentiating with respect to x again, what we will get? D by dx of dy by dx is equal to d by dx of this 3 times x plus 3 whole square. Now here again 3 constant. This is f of x to the power of n. What is n? N is 2 into x plus 3 to the power of 2 minus 1. 3 2s are 6. X plus 3 to the power of 2 minus 1 is 1, and derivative of x is equal to 1. That's it. So the required answer is 6 times x plus 3 to the power of 1. That is nothing but 6 times x plus 3 is the required answer. That's it. Okay. This is how we are going to get the second derivative for the given function. Now let us move on to next problem. If y is equal to log x, find d square y by dx square. Now what is given? Y is equal to logarithm of x to base c. Now differentiating this with respect to x. Now differentiation of log x. You know what is d by dx of log x? 1 over x. Differentiation of log x is 1 over x. Differentiate again with respect to x, then what you will get? D by dx of dy by dx is equal to d by dx of 1 over x. Now here this is d by dx of dy by dx is nothing but d square y by dx square is equal to, you know what is the derivative of 1 by x? It is minus 1 by x square. That's it. Derivative of 1 by x is minus 1 by x square. Now move on to the next problem. If y is equal to x cube plus tan x, find d square y by dx square. Now differentiate this. Differentiating with respect to x. Now what we will get? Dy by dx is equal to differentiation of x cube is 3x square plus differentiation of tan x is secant square x. This is first derivative. Differentiate again. Differentiating with respect to x again. Then what we will get? D square y by dx square is equal to term by term differentiation of d by dx of 3x square plus d by dx of secant square x. Now here this can be written as d square y by dx square is equal to 3 constant, differentiation of x square is 2x plus again this is function of a function n is 2 secant x into differentiation of secant x is secant x into tan x. So therefore we can write y double dash d square y by dx square is equal to 6x plus 2 into secant is secant square x into tan x. This is how we are going to find the second derivative for this function. Now move on to the next problem. Now this is also a very important type problem for 2 marks. If y is equal to a sin x plus b cos x, prove that d square y by dx square plus y is equal to 0. Now what is given? Y is equal to a sin x plus b cos x. Let us represent this as equation number 1. Differentiating with respect to x, what we will get? Dy by dx is equal to a constant, differentiation of sin x is cos x plus b constant, differentiation of cos x is minus sin x, right? Now differentiate again. Differentiating with respect to x, again if you differentiate, on the left hand side what we will get? D square y by dx square is equal to a constant, derivative of cos x is minus sin x plus into minus it is minus b into derivative of sin x is cos x. So you can take minus out. If you take minus out, a into sin x, this minus is gone, what is remaining is plus b cos x. Now minus into a, minus a sin x plus b cos x. Now this can be written as minus of y from equation number 1. That is from 1, what do you write? A sin x plus b cos x is nothing but y. So transfer this to the left hand side. D square y by dx square is equal to minus y, means therefore d square y by dx square plus y is equal to 0, which is a required proof. D square y by dx square plus y is equal to 0. Very simple problem it is, right? Now you may expect this type of problems in differential equations also. Now move on to the next problem. Now these are all very important problem for 5 marks. Now definitely we'll get sure 1 5 marks question from this concept. Now what is given? Y is equal to sin inverse of x. Prove that 1 minus x square into d square y by dx square minus x dy by dx is equal to 0. Now let us represent y is equal to sin inverse of x as equation number 1. Differentiating with respect to x. So differentiation of y dy by dx, you know what is derivative of sin inverse x? 1 by root of 1 minus x square. Cross multiply this. Root of 1 minus x square into dy by dx is equal to 1. Now differentiate this with respect to x on both sides. Differentiating with respect to x on both sides again. Now if you differentiate with respect to x on both sides, what we will get? D by dx of root of 1 minus x square into dy by dx is equal to d by dx of 1. Now this can be differentiated using product rule, UV method. U first function and second function. First function root of 1 minus x square constant. Differentiation of dy by dx is d square y by dx square plus dy by dx constant. Derivation of root x is 1 over 2 root x into d by dx of inside function. 1 is 0, x square is 2x minus 2x, and derivative of a constant is 0. So here this 2 and 2 gets cancelled. Root of 1 minus x square into d square y by dx square minus 1 into x is x into x by root of 1 minus x square into dy by dx is equal to 0. Now just multiply by root of 1 minus x square. Multiply by root of 1 minus x square. Root of 1 minus x square into root of 1 minus x square is root of 1 minus x square y whole square into d square y by dx square. Multiply by root of 1 minus x square. Root of 1 minus x square into root of 1 minus x square is root of 1 minus x square whole square d square y by dx square minus these 2 gets cancelled. Root of 1 minus x square, root of 1 minus x square gets cancelled. What is left over is x into dy by dx is equal to, on the right hand side 0 into number is 0. Here square and square root gets cancelled. Therefore 1 minus x square into d square y by dx square minus x dy by dx is equal to 0, which is the equivalent. So therefore you can write, therefore 1 minus x square into d square y by dx square can also be written as y2 minus x into dy by dx can also be written as y1. So 1 minus x square into y2 minus x y1 is equal to 0 is the required answer. If you do this much, definitely you will get 5 marks. Very important type problem. Now similarly, there is a same question for cos inverse x also. Now move on to the next problem. What is the next problem? If y is equal to 3 into e to the power of 2x plus 2 into e to the power of 3x, prove that d square y by dx square minus 5 dy by dx plus 6y is equal to 0. Right. Now let us represent this. Y is equal to 3 into e to the power of 2x plus 2 e to the power of 3x as equation number 1. Right. Okay. Now differentiate this. Differentiating with respect to x. So dy by dx is equal to, there is one formula, d by dx of e to the power of ax is equal to a e raised to ax. So here d by dx of e to the power of 2x is 2 e raised to 2x. Similarly, d by dx of e to the power of 3x is 3 e raised to 3x. Right. So this is 3 into differentiation of e raised to 2x is 2 e raised to 2x plus 2 into differentiation of e to the power of 3x is 3 e raised to 3x. Therefore, this can be written as dy by dx is equal to 6 e power 2x plus 6 e power 3x. Now differentiate this again. Differentiating with respect to x again. Differentiating with respect to x again, if we differentiate, we will get the second derivative, that is d square y by dx square is equal to 6 into, again d by dx of e to the power of 2 is 2 e raised to 2x plus 6 into differentiation of e raised to 3x is 3 e raised to 3x. So this is equal to 6 2s are 12 e to the power of 2x plus 6 3s are 18 e to the power of 3x. So this is dy by, yes, y value, this is dy by dx, and this is d square y by dx square. Now substitute d square y by dx square, dy by dx and y in equation number 1, you will get the answer. Now take LHS. Now let us write the LHS. LHS d square y by dx square minus 5 dy by dx plus 6y. What is to prove? This is equal to 0. Now substitute the value of d square y by dx square. What is d square y by dx square? 12 e to the power of 2x plus 18 e to the power of 3x minus 5 into dy by dx. What is dy by dx? 6 into e to the power of 2x plus 6 into e to the power of 3x plus 6 times, what is y from 1? Y is equal to given equation 3 e to the power of 3 e to the power of 2x plus 2 e to the power of 3x. This is from 1. Now multiply and simplify. You are going to get the answer as 0. That's it. This is as it is. 12 e raised to 2x plus 18 e to the power of 3x 5 6 are 30 e raised to 2x minus into plus minus 5 6 are 30 e to the power of 3x plus 6 3s are 18 e to the power of 2x plus 6 2s are 12 e to the power of 3x. Now cancel the terms which gets cancelled. Now here nothing will get cancelled. Now just simplify this. Now e to the power of 2x, 12 e to the power of 2x minus 30 e to the power of 2x, 18 e to the power of 2x. 12 plus 18 is 30. 30 e to the power of 2x minus 30 e to the power of 2x plus 18 e raised to 3x, 12 e raised to 3x is 30 e raised to 3x minus 30 e to the power of 3x. Now cancel the terms. Plus 30 minus 30 e raised to 2x plus 30 minus 30 e raised to 3x gets cancelled. This is equal to 0. That is the required answer. That's it. Alright. First find out dy by dx, d square y by dx square, and substitute in the given equation d square y by dx square minus 5 dy by dx plus 6y. You will get the answer as 0. That's it. Okay. Now move on to the next problem. This is the general problem of this. So this is the general problem for the previous one. See, y is equal to a into e to the power of mx plus b e to the power of nx. Prove that d square y by dx square minus m plus n dy by dx plus mn y is equal to 0. Same problem. That is nothing but d square y by dx square m plus n. 3 plus 2 is 5. 3 into 2 is 6. So that is nothing but m plus n dy by dx plus mn y is equal to 0. Same concept. Now what is given? A into e to the power of mx plus b into e to the power of nx. Let us represent this as equation number 1. Differentiate it. Differentiating with respect to x. So if you differentiate this, dy by dx is equal to a constant. Differentiation of e to the power of m is m e to the power of mx plus b constant. Differentiation of e to the power of nx is n e to the power of nx. Now differentiate this again. Differentiating with respect to x. Again if we differentiate, on the left hand side we will get d square y by dx square is equal to a into m constant. Again d by dx of e to the power of mx is m e to the power of mx, b into n constant. Differentiation of e to the power of n is n e to the power of nx. So this can be written as a into m is m square e raised to mx plus b n into n is n square e to the power of nx. So y dy by dx, d square y by dx. Substitute this in the left hand side of the given equation. What is LHS? This is LHS. LHS is d square y by dx square minus m plus n dy by dx plus mn into y. What is the answer we want to get? On the right hand side it is 0. Substitute it. What is d square y by dx square? A into m square e to the power of mx plus b into n square e to the power of nx. Next, minus m plus n into, what is dy by dx? dy by dx is a into m e to the power of mx plus b into n e to the power of nx plus mn into y. What is y? Y is equal to a into e to the power of mx e to the power of mx plus b into e to the power of nx. That's it. Okay. Now just multiply and simplify. This is equal to, as it is, a m square e to the power of mx plus b n square e to the power of nx. Now multiply with m first. M into m is m square e to the power of mx plus b, m into n is mn e to the power of nx. Again multiply with n then, plus n a into mn e to the power of mx plus b, n into n is n square e to the power of nx. Now just multiply this with mn. So mn a e to the power of mx plus mn b e to the power of nx. Okay, now this is equal to x. Now just this is as it is, a m square e to the power of mx plus b n square e raised to nx. Now multiply by negative side. This is a m square e to the power of mx minus into plus minus b into mn e to the power of nx, mn. Next, minus a mn e to the power of mx, minus into plus minus b n square e to the power of nx, m. Next, the last term, plus mn into a e to the power of mx plus mn into b e to the power of nx. Now cancel the terms which gets cancels. Now first, a m square e raised to mx plus a m square e raised to mx minus c minus n plus gets cancelled. Again b n square plus b n square, again minus b n square e to the power of nx e to the power of nx gets cancelled. Now x bmn minus bmn e raised to nx plus bmn e raised to nx gets cancelled. And last, amn e raised to mx plus amn e raised to x plus n minus gets cancelled. Everything gets cancelled. So this is equal to 0, which is RHS, the required answer is equal to 0, the required RHS. This is how we are going to solve. Very simple and very important and easiest problem. Okay. Now move on to the next problem. Now let us come to the next problem. If y is equal to 3 cos log x plus 4 sin log x, show that x square into y2 plus xy1 plus y is equal to 0. This is also an important problem for 5 marks. What is given? Y is equal to 3 cos of log x plus 4 sin of log x. Let us represent this as equation number 1. Differentiate this. Differentiating with respect to x. This is dy by dx is equal to 3 into differentiation of cos x minus sin log x into d by dx of log x is 1 over x plus 4 constant differentiation of sin is cos log x into differentiation of log x is 1 by x. Now just multiply by x on both sides. X into dy by dx is equal to x and x gets cancelled, minus sin 3 log x plus 4 times cos of log x, x and x gets cancelled. Now differentiate again. Differentiating with respect to x again. So if you differentiate, same as usual, this is UV method, product rule. I'll write here. I'll go to the next page. D by dx of x into dy by dx is equal to d by dx of, I'll take this, minus 3 sin log x plus 4 cos log x. Now differentiate this. Okay. Now to differentiate, this is product rule, UV method, u and v. First function, x into differentiation of dy by dx is d square y by dx square plus second function dy by dx into differentiation of x is 1. Again this is as ordinary differentiation. 3 into differentiation of sin is cos log x into differentiation of log x is 1 over x plus 4 into differentiation of cos is minus sin minus 4 sin log x into differentiation of log x is 1 by x. Now just multiply by x again. Multiply by x on both sides. What happens? X into x is x square d square y by dx square minus plus x into dy by dx is equal to x and x gets cancelled, minus 3 cos log x, again x and x gets cancelled, minus 4 sin of log x. Now this can be written as x square into d square y by dx square plus x into dy by dx is equal to, you can take negative sign out, minus out, 3 cos log x minus into minus plus 4 sin log x, right. So what is this equal to? So therefore x square d square y by dx square plus x dy by dx is equal to minus y. This is y from equation number 1. X d square y by dx square plus x dy by dx minus is equal to minus y. So what is to prove? Just bring this to the left hand side. So therefore x square into, this can be written as y2 plus xy1 dy by dx is y1, minus y can also be written as plus y is equal to 0. See here, just x square into d square y by dx square is y2 plus x into dy by dx is y1, and transfer minus y to the left hand side, minus y becomes plus y is equal to 0. X square y2 plus x y1 plus y is equal to 0 is the required answer. Very, very important and very easiest problem. I expect this also for a 5 marks. Very important problem indeed. Okay, right. Now move on to the next problem. What is the problem given? E to the power of y into x plus 1 is equal to 1. Now prove that d square y by dx square is equal to dy by dx whole square. Now this can also be written as, so here this is e to the power of y is equal to 1 over x plus 1. Taking log on both sides, then this can be written as logarithm of e to the power of y to base e is equal to logarithm of 1 by x 1 plus x or x plus 1. So this is nothing but y log e to base e is equal to logarithm of 1 minus logarithm of 1 plus x. Log e to base e is equal to 1 and log e to logarithm of 1 to base e is 0 minus logarithm of 1 plus x. So therefore we can write y is equal to minus of log 1 plus x or x plus 1. Let us represent this as 1. Now differentiate this. Differentiating with respect to x. So dy by dx is equal to minus differentiation of log x is 1 by 1 plus x and differentiation of x is 1. So this is minus 1 over 1 plus x. Let us represent this as equation number 2. Right. Now differentiate this again. If you differentiate this again, differentiating with respect to x again on both sides, what we will get? D by dx of dy by dx is equal to minus of, that is d by dx of minus of 1 by 1 plus x. Now d by dx of this is d square y by dx square is equal to minus out. Since you know what is the derivative of 1 by x, d by dx of 1 by x is minus 1 by x square. So minus of d by dx of 1 by this is minus 1 by 1 plus x whole the square. Minus into minus, it is plus 1 by 1 plus x whole square. Let us represent this as equation number 2. Now from 2 and 3, what is 2 we have? 2 is dy by dx is equal to minus 1 by 1 plus x. Square this. If you square this on both, squaring on both sides, what we will get? Dy by dx whole square is equal to minus 1 by 1 plus x whole square can be as 1 by 1 plus x whole square. What is 1 by 1 plus x whole square from equation number 3? It is d square y by dx square from equation number 3. Right. So dy by dx whole square is equal to d square y by dx square. Dy by dx whole square is equal to d square y by dx square. So therefore from this we can say that therefore dy by dx whole square is equal to d square y by dx square, which is the required answer. See here, dy by dx whole square is equal to d square y by dx square, because dy by dx is minus 1 by 1 plus x square. If you square that, minus into minus plus 1 by 1 plus x whole square is nothing but your second derivative d square y by dx square. Very important problem, right? Now move on to the next problem. Here this is also very important problem. If y is equal to tan inverse of x whole square, show that x square plus 1 into x square plus 1 whole square y2 plus 2x x square plus 1 into y1 is equal to 2. Now what is given here? Y is equal to tan inverse of x whole square. Differentiate this. Differentiating with respect to x, dy by dx is equal to, what is n? N is 2. 2 tan inverse of x into differentiation of tan inverse x is 1 by 1 plus x square. Cross multiply this. 1 plus x square into dy by dx is equal to 2 tan inverse of x. Now differentiate again. Differentiating with respect to x again on both sides. What we will get? So this is product rule. First function second function 1 plus x square into differentiation of dy by dx is d square y by dx square plus second function dy by dx into derivative of 1 is 0, x square is 2x is equal to again 2 into derivative of tan inverse x is 1 by 1 plus x square, again multiply by 1 plus x square on both sides. So what happens, 1 plus x square into 1 plus x square is 1 plus x whole square into d square y by dx square plus this is dy by dx into 2x into 1 plus x square. 1 plus x square, 1 plus x square gets cancelled, 2 into 1 is 2. So put it in order. So therefore, x square plus 1 whole square into d square y by dx square can also be written as y2 plus 2x into x square plus 1 into dy by dx is y1 is equal to 2, which is the required answer. See, x square plus 1 whole square into y2 plus 2x into x square plus 1 y1 is equal to y is the required answer. Hope you followed. This is also very important for the point of examination. So definitely you will get one question from this for 5 marks, no doubt in it. This is a sure question. Now move on to the 3-marker question. The next concept is the Rolle's theorem. Now what is Rolle's theorem? So Rolle's theorem states that let f from a to b closed interval, if f from a closed interval a to b to r is continuous, if a function f from a comma b to r is continuous on the closed interval ab, continuous on the closed interval ab and differentiable on the open interval a comma b, and if f of a is equal to f of b, functional value of a, f of a and f of b are equal, where a and b are some real numbers, then there exists a c which lies between a and b, that is c belongs to a comma b such that f dash of c is equal to 0. So if f from a comma b, if f from closed interval a comma b to r is a continuous function on the closed interval ab, if f is a continuous function and f is differentiable on the open interval a comma b, and if f of a is equal to f of b, if these three conditions are satisfied, then there exists one value c which lies between a and b such that f dash of c is equal to 0. F dash of c is equal to 0. That is called the Rolle's theorem. Now verify, now in the examination they may ask 3 marks question. Verify Rolle's theorem for the function y is equal to x square plus 2 at a is equal to minus 2 and b is equal to plus 1. Now what is given here? F of x is equal to x square plus 2. And the interval a comma b is equal to minus 2 comma 2. The closed interval a comma b is equal to minus 2 comma 2. Now first condition, what is the first condition? Since f of x is a polynomial, this is a polynomial function in x, so therefore f of x is continuous in the closed interval minus 2 comma 2. Since this is a polynomial in x, therefore this is continuous in the closed interval minus 2 comma 2. Now differentiate this. If you differentiate this, differentiating with respect to x, second condition, differentiating with respect to x, what happens? F dash of x is equal to f dash of x, derivative of x square is 2x. So that means that is differentiable in the open interval minus 2 comma 2. So differentiable in the open interval minus 2 comma 2. And verify f of a and f of b. So what is f of a? F of minus 2. F of minus 2 is minus 2 square plus 2. Minus 2 square is 4 plus 2 is equal to 6. F of b, f of 2, 2 square plus 2. 2 square is 4 plus 2, that is also equal to 6. So f of minus 2 is equal to f of 2. All the conditions for Rolle's theorem is satisfied. F of x is continuous, f of x is differentiable, and f of a is equal to f of b. All the three conditions for Rolle's theorem is satisfied. Hence there exists c belongs to a comma b such that f dash of c is equal to 0. What is f dash of x? F dash x is 2x. F dash of c means 2c is equal to 0. Therefore, c is equal to 0 by 2 is equal to 0. belongs to minus 2 comma 2. That's it. So C 0 which belongs to minus 2 comma 2, thus the Rolle's theorem is verified. That's it. So if you do this much, definitely you will get 3 marks. Now move on to a similar type problem. Take this. Verify Rolle theorem for the functions f of x is equal to x square plus 2x minus 8 in, what is the interval given? Minus 4 comma 2. A is equal to minus 4, B is equal to 2. Since, same as usual, since f of x is a polynomial in x, therefore f of x, therefore it is continuous. Therefore it is continuous in the closed interval minus 4 comma 2. Therefore it is continuous in the closed interval minus 4 comma 2. Now differentiate. Differentiating with respect to x, then f dash of x is equal to 2x plus 2. That is differentiable in the open interval minus 4 comma 2. Now verify f of a, third condition. F of a, f of minus 4 is equal to 4 square is 16 plus 2 into minus 4 minus 8. That is 16 minus 16 is equal to 0. And f of b, f of 2 is 2 square, then plus 2 into 2 minus 8. That is 2 square is 4 plus 4 is 8 minus 8, that's equal to 0. So f of a is equal to f of b. All the conditions for Rolle's theorem is satisfied. Hence there exists C belongs to a comma b such that f dash of c is equal to 0. What is f dash of x? 2x plus c. F dash of c is 2c plus 2. 2c plus 2 is equal to 0. 2c is equal to minus 2. C is equal to minus 1 belongs to minus 4 comma 0. That's it. So this is how we are going to verify the Rolle's theorem. Right. Now move on to the one more problem. Verify Rolle's theorem for the function f of x is equal to x square minus 1. Same. Since f of x is polynomial in x, therefore f of x is continuous in the closed interval 1 comma 2. And differentiate it. F dash of x is equal to 2x, that is differentiable in the open interval 1 comma 2. Now and f of a, f of 1 is equal to 1 square is 1 minus 1 is 0. F of b, that is f of 2. F of 2, 2 square is 4 minus 1, that's equal to 3. See here, f of a is not equal to f of b. 1, 0 is not equal to 3. That means what? All the conditions for Rolle's theorem is not satisfied. Therefore, Rolle's theorem does not exist. Rolle's theorem does not exist. All the conditions for Rolle's theorem is not satisfied. So Rolle's theorem does not exist for this problem. Now move on to the next next condition. If Rolle's theorem does not exist, then we will go for the next theorem, that is called the Lagrangian mean value theorem. Lagrangian mean value theorem, LMV, or it is also called as mean value theorem. Mean value theorem. What is mean value theorem? The first two conditions are same. Let f from a comma b to r be a continuous function on the closed interval a comma b and differentiable in the open interval a comma b, then there exists c belongs to a comma b such that f dash of c is equal to f of b minus f of a, provided f of a is not equal to f of b. If f of a is not equal to f of b, then there exists c belongs to a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. So if Rolle's theorem fails, we will apply mean value theorem. Now verify this. Verify mean value theorem for the function f of x is equal to x square in a is equal to 2 and b is equal to 4. See, since f of x is polynomial, polynomial function in x, therefore it is continuous. It is continuous in the closed interval 2 comma 4. Now differentiate this. If we differentiate, f dash of x is equal to 2x, that is differentiable in 2 comma 4. Next, and verify whether f of a and f of b, f of 2 square is equal to 4. F of b, what is 4? 4 square. 4 square is equal to 16. That is, f of a is not equal to f of b. All the three conditions for mean value theorem is satisfied. Hence, f dash of c is equal to, we can write f dash of c is equal to f of b minus f of a divided by b minus c. What is f dash of c? 2c is equal to f of b. What is f of b? 16 minus 4 divided by b minus c. 4 minus 2. What is 16 minus 4? 16 minus 4 is 12 divided by 2 is 6. So, 2c is equal to 6, c is equal to 6 by 2 is equal to 3, which belongs to 2 comma 4. That's it. So, the required answer is 3 in this case, which belongs to 2 comma 4. Now, move on to the last problem in this. Verify mean value theorem for the function. What is given? X square minus 4x minus 3 in the interval a comma b, where a is equal to 1 and b is equal to 4. Now, what is given? F of x is equal to x square minus 4x minus 3. Now, as usual, what is a here? A is equal to 1 and b is equal to 4. That is the closed interval 1 comma 4. So, f of x, since f of x is polynomial, is a polynomial function in x, therefore it is continuous. Therefore, the function is continuous in the closed interval 1 comma 4. It is continuous in the closed interval 1 comma 4. Now, differentiate this. F dash of x is equal to 2x minus 4. That is differentiable in the open interval 1 comma 4. Now, f of a, verify f of 1. 1 square is 1 minus 4 minus 3 is minus 6. F of b, f of 4, 4 square is 16 minus 16 minus 3, that is equal to minus 3. That is, f of a is not equal to f of b. All the condition for mean value theorem is satisfied. Therefore, f dash of c is equal to f of b minus f of a divided by b minus a. That is, what is f of b? F of b is minus 3 minus f of a is minus of minus 6 divided by 4 minus 1. That is nothing but minus 3 plus 6 by 3. 3 by 3 is equal to 1. What is f dash c? F dash c is nothing but f dash x is 2x minus 4. So, 2c minus 4 is equal to 1. 2c is equal to 1 plus 4, that is equal to 5. Therefore, c is equal to 5 by 2 belongs to 1 comma 4, such that f dash of 5 by 2 is equal to f of b minus f of a divided by b minus c. So, therefore, c is equal to 5 by 2 is the required answer. Hope you followed. This is how we are going to solve a 3-mark question in case of Rolle's theorem as well as in mean value theorem. That's it. Okay. That's all regarding today's session. Hope you followed. So, this is very important session. You just practice all the problems. Definitely will get this question for the final examination. Let us meet with different concept in the next session. Thank you very much.